All right, welcome to Chapter 9, Section 1 for Statistics and Parameter. This is for Integrated Math 1. So the first thing that you will see on your screen is the due date. I don't see that here, but you'll see it on your student side. The second thing you're going to see is the number of attempts. You always have unlimited attempts on your homework tests and quizzes. Number of questions just tells you how many questions are on this particular assignment. Grading policy is always best scores. Whichever attempt is the best one is the one you keep. And partial credit's enabled, so if you answer 1 or 2 questions correctly, you get credit for the one question or however many you answered correctly. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. So that means that once I click start, down here in the bottom right corner, you will see the submit assignment button. You don't see it on my screen here, but you will see it on your student side. And you want to click this button for 2 big reasons. The first one is just like that other one said, until you finish your assignment, which means click on that submit assignment button, you can't work on anything else. It means pretty much everything in Alex is locked out to you. If you just go up here and you close this tab or you close your computer, it's going to leave this attempt open. And it locks everything else, even the resources. So remember, you have unlimited attempts. You don't need to leave this attempt open. As long as you have a green check mark, it's going to save your progress. You're not going to have to start over. So that's not a big deal. So just make sure you click that so it doesn't lock you out of everything. The other big reason is that it actually affects the grade book once you click submit assignment. So your teacher can see what you've been working on. Till you click that button, your account's basically paused. We can't see anything. So, just good habit. Always make sure you click that button. All right, on the side here, we have these 4 resources. The calculator's not always available, but sometimes it is. So right now we do have the calculator, but we always have explanation, example, and message center. So explanation tells you you're going to lose your current question attempt because it's going to explain this problem to you. It's going to give you a solution. So it's not going to give you the answer and then let you come type it in. Sorry, not how this works. Example will show you exactly how to solve a problem just like this one. So it will show you how to do what's called the mean absolute deviation, which I'll explain in just a moment. You can open another example once you're happy with that one. And message center, you can message your teacher directly from the screen. It'll attach a picture of the problem so that your teacher knows where to come help you. All right, let's go ahead and get started on this guy. So there's 2 types of deviations we're going to do. So the first one, this number 1, is mean standard deviation, or mean absolute deviation, sorry. The second one is population standard deviation. So we want to make sure we're paying attention to the name because that will change the steps just a little bit. So if we think about the words for mean, dang it, my cord keeps getting in my way here. Let me change up my color here just so that it's easier to see. So we have mean, absolute, deviation. Deviation, I want to make sure I'm spelling deviation right because that would be silly. All right, so mean is another word for average. So if I take the average of the numbers, so average, absolute has to do with distance, because we're talking about like absolute value, distance, and then deviation, that's another word for like differ. So if we kind of break that down, we go, on average, how does the distance differ? Sometimes that's a little easier to kind of think about. Instead of mean absolute deviation, it sounds very fancy. But really, we're just going to look at how do the values differ in distance from the mean, so from the average. So it's just kind of a name for it. We have 3 main steps. So our first step is to find the mean or the average. So we've already been doing, oh, nope, sorry, that was a different class. We have not been doing this yet. So this is the first time we're kind of reviewing how to do average. So we want to find the mean. To do that, we're going to add all values. So we're going to add all these values, and then we're going to divide. I'll say then divide by the number of values there are. So I can count them here, but I can also see it tells me there are 7 values. So I know there's 7 numbers, 1, 2, 3, 4, 5, 6, 7 values within this data set. So divide by the number of values in the set or data set. All right, so let's go ahead and take a look at that. So And with this one, I know it's done it for me before. Let's see if it'll do it again. If I go like this, it won't click and send them there, but that's okay. So we'll go ahead and add these guys together. So we have 12 plus 10 plus 13 plus 20 plus 15 plus 16 plus 19. I want to make sure I didn't type any of those wrong. Let's see, we have 12, 10, 13, 20, 15, 16, 19. So the biggest thing I see mistake-wise is either it was typed in the calculator wrong as far as adding, or one of the numbers was forgotten. So just double check. Make sure you can always re-add them. Make sure you get the same number again. So we have 105 for the sum. I added them all together. And now I need to divide by the number of values there were, which is 7. So this gives me the average, or the mean. So here's our mean. Now, for step number 2, I want to find the distance from each value and the mean. So distance, average, because we want to know how much do they differ. Oh, look at all these words coming back in here. All right, so for each one, and I'm just going to write them down. I'm going to go 12, 10, 13, 20, 15, 16, 19. And if you've done this on the notes page, it should look something very similar to this. It was just typed out instead of, handwritten like this, but something very similar. So I'm going to use the mean here, and I'm going to subtract each one. The big thing here is I'm kind of looking at distance. How far away is it? So these need to be absolute values. So I'm going to go absolute value. So if I get a negative, I'm going to kind of drop the negative away. Not necessarily that I don't care that it's negative. I just want to know how far away is it from the mean, either left or right. I don't want to include the negative sign. So we have 12 minus 15. Well, that would be a negative 3. So I'm just going to say 3. I don't know why I changed that to the wrong blue. So it would be negative 3, but I'm going to ignore the negative because I just want the absolute value. 10 minus 15, again, that would be negative 5, but absolute value makes it just 5. 13 minus 15 gives me negative 2, which I dropped to just 2. 20 minus 15 is 5. 15 minus 15 is 0. 16 minus 15 is 1. And 19 minus 15 is 4. All right, so that was my second step. So far, yes, it's a couple steps to remember, but they're not super complicated steps. So first I need to find the mean. I have to add them all together and divide by however many I have. That gives me my mean. Then I need to subtract each number from the mean, and these are my differences. So these are all the differences from the mean. The third step, we want to find the mean of the differences. Mean of the differences. So I want to, again, to find mean, I need to total them all up. So I'm going to need to add them all up again. Just like here, I'm going to add all the values, then divide by the number of values in the set. Well, there should still be the same number of values. They're going to be different values, but there should still be 7 of them because I subtracted from the 7 numbers we started with. So let's go over here. We have 3 plus 5 plus 2 plus 5 plus 0 plus 1 plus 4. So that's 20 divided by 7. Because there's 7 numbers here. 1, 2, 3, 4, 5, 6, 7. So again, I'm finding the mean of the differences because it's the mean absolute deviation. So I want to know what is the average of the difference between the mean, what the actual mean is, and the value. Divided by 7 equals. So we go 2.85714 ... It just kind of keeps going. And it says to round to the nearest hundredth. So remember when I'm rounding, here's a hundredth right here, 2.85. I need to look at that last number right there because the 7 is actually going to tell me, do I round this up to the next value or do I just cut all that off? Well, it's 5 or bigger, so this is going to round up to the next value, which is 6. So this is going to be 2.86. All right. So that's mean absolute deviation. I find the mean. I subtract the differences, make sure it's absolute value. So no negatives here. And then find the mean one more time using the differences. So that's the mean absolute deviation. The next one we're going to do here is called standard, the population standard deviation. So similar steps, but not exactly the same. So we're going to do something a little bit different. So with this one, the first step, we're still going to find the mean. So that's still the same idea. We're finding the mean. So we're going to go like this, and this one's pretty easy. These numbers are smaller, but we'll go ahead and add them this way. 6 and then plus 0, which doesn't do anything. 1, 4, 3, 4, 6, 0. Perfect. So I have 18 over, and I can say there's 6 participants, or I can count 1, 2, 3, 4, 5. So 6 participants in a weight loss class lost the following weights in pounds after 3 weeks of dieting. Now for this one, and this was a very bad teacher move on my part, I didn't read that out loud because no matter what the story is, I'm going to calculate standard deviation the same way. So really it doesn't matter what the story is, they're just giving you some context there, but you're going to do the standard deviation exactly the same way. So I know I was finding, assuming that these weights constitute an entire population, find the standard deviation of the population. So I knew we were looking for standard deviation here, and I just kind of jumped in. We should always read the problem first, so sorry about that. I was jumping in from my notes page over here. All right, so we're going to divide by 6. So 18 divided by 6, well, that gives us 3. So our average, or our mean, is 3. The second step, we're going to do kind of the same thing we did before. We're going to find the difference. Find the difference. Find the difference of each value, and the mean. So that's very similar to what we did on the last one. But instead of it being the absolute value, then we square it. Then square it. All right. So if I write down these 1, 4, 3, 4, 6, 0, and then I'm going to subtract the mean here, which I'll kind of highlight in blue. So we're going to go minus 3, minus 3, minus 3, minus 3, minus 3, minus 3. And we have equals. So I'm going to go 1 minus 3. Well, that's negative 2. And then I'm going to square that. Negative 2 squared is positive 4. So you notice how the negative still disappears? Because I'm using a square. 4 minus 3. Well, that's 1. 1 squared is 1. 3 minus 3, that's 0. 0 squared is still 0. 4 minus 1, that's 1 again. 1 squared is 1. 6 minus 3 is 3. 3 squared is 9. And then 0 minus 3, that's negative 3. Negative 3 squared is also 9. So make sure, you notice how I put a parentheses around the negative. If you type this in to the calculator, see if this one does it the right way. So I'm going to square it. And it says negative 9. And the reason it didn't get rid of the negative is because I didn't put the parentheses around the negative 3 like this and then square it. I'm not telling the calculator that the negative is included. So if I just have the negative 3, it's only going to square the 3. But if I have negative 3 in parentheses, then it's going to square them both correctly. So I didn't put parentheses around the positives because it's not going to make any difference. But around the negative, it does make a difference when you type that in the wrong way. So just be very careful about that. All right, so number 3, we're going to find the mean again. So find mean. Find mean of differences. Differences. Okay. So I'm going to do the same thing I did before. So I'm going to have 4 plus 1 plus 0 plus 1 plus 9 plus 9. So I get 24. And I still have 6 numbers. 1, 2, 3, 4, 5, 6. So 24 divided by 6, well, that's 4. So this is kind of nice. We're not ending up with any decimals. Actually, we won't on the next one. Normally, we end up with decimals on this one. So the fourth step, so this one does have a fourth step, so a little bit different. We didn't do the difference of the absolute values. We did the difference and squared it. So that's really the main difference so far. The last step is, instead of just stopping at 4 like we did on the mean absolute deviation, we actually need to take the square root of that answer. So So the square root of that answer would be 2. So the standard deviation, the amount that it differs from the mean, is on average 2. Or not on average. This is a mean absolute value. But it has one standard deviation of 2. So from the mean mark, we would move out 2 units on either side. All right, so let's go ahead and check that guy. Perfect. Yeah, normally we don't have these nice numbers like 3, 4, 2. Normally you have decimals. So be careful about intermediate rounding too, like within here if you have to round. Try not to do any intermediate rounding because that can mess up some of the calculations as you move forward. But definitely rounding at the end. It even tells us, round your answer to 2 decimal places. And I guess that's kind of if necessary. All right, that was section 1. I will see you in section 2.